The challenge has existed for over 4 decades now on how to mark, describe, and most importantly, warn about a geological repository. The outcomes of the initiatives in the early 1980s still are spooking around in the media, even though some of them have been dismissed shortly after publication by the authors themselves. The challenge is still open: how to pass on information about a nuclear waste repository to a distant society. One suggestion is to achieve this in the form of a nuclear message. First, let's analyze the purpose of this message, and second, who the addressees are. The immediate answer to the purpose question is warn future generations about the danger of nuclear waste. But we are speaking about time frames where highly radioactive waste already decays into, subject to contemporary interpretation, low-level or non-hazardous materials. Answering who the addressees are quickly comes down to those who have an understanding what radioactivity is. It does not make any sense to try to warn societies on a technical level comparable to the Bronze Age, or 16th century, or even early 20th century. They simply won't have the skills and means to drill deep and accidentally hit a geological repository. In fact, a nuclear message serves one purpose: pass on information to societies who understand what fission is. Only they will have the technical means to uncover a nuclear waste repository. This argument is based on the assumption that technical societies develop in a similar way throughout the universe. Even if science fiction suggests otherwise, there simply will be no technical society that discovers quantum physics before they invented the steam machine. More and more precise manufacturing is crucial to get deeper insights into the nature of the universe. This means a nuclear message should contain information how much of which material is deposited where and since when. But how could this be written down in a way to an unknown recipient with an unknown system of communication? Frankly speaking, every language we speak today is a dying language, and the symbols we use today have arbitrary meanings. In analogy to the preceding argument, a society on a technical level comparable to ours must have a more or less identical understanding of the order of matter and the fundamental forces. Even if it's a technically much more advanced society, it must have passed a waypoint where we currently stand during their epistemological journey. Although icons and symbols need context to be correctly interpreted, there are icons which have a universal context. Those icons are understood throughout the universe. For example, any tool using civilization understands the depiction of a hammer. A hammer has been and always will be a solid stick with a massive part mounted on the other end as where you hold it. Never would a hammer be a softball on a string. Or a balance. Wherever gravity exists, a balance to measure weight would be constructed in the same way. On earliest depictions, balances look identical to mechanical balances we use today. Another example of a universal icon is the periodic system. It is not at all a random table. As soon as a technical society discovers the elements and explains radioactivity, the periodic system is only a consequence. Pointing to a position already explains material. These universal icons allow communication across space and time. A nuclear message should be made from strong material without value, and it can work as unit for length and weight itself. It is essential for a recipient of the nuclear message to know the age of the repository in order to assess the current status of the content and to evaluate the risk a retrieval would entail. There are various methods for indicating today, such as extremely rarely occurring astronomical constellations, or by properties of the material itself the nuclear message is made of. And there is a dimension that goes beyond making the effort to inform future societies about what we bury deep in the ground. The much broader aspect of a long-term recycling notion. Beside the nuclides, there are huge volumes of stainless steel and copper, altogether precious material. If we would just bury and forget it in geological formations where no decent geologist would ever assume such material, we would deprive future societies from reusing these vast amounts of valuable stuff. Anticipating reuse in the distant future and allowing a society that has nothing in common with us to benefit from our current efforts is a sign of humility and responsibility to the planet's biosphere, traits that humanity as a species is lacking today, and where the nuclear industry could gain a name and serve as a role model for how to treat our legacy, especially waste with no half-life. By this, the nuclear message is more than passing on information to the future. It is as well a signal to and statement of the present society.